Our directions for these next three say find the surface area and volume of each composite. So for surface area, we basically have the lateral area of the cone and half of the sphere. But notice the base of the cone or the great circle of the sphere is interior and is not considered surface. So lateral area of the cone, pi RL, plus half of a sphere, half of 4 pi r squared, or pi RL plus 2 pi r squared, gives me pi times r, which is 7, times L, which is 25, L slant height, plus 2 times pi times 7 squared. 7 times 25 is 175 pi. 2 times 7 squared is 98 pi. 175 and 98 is a total of 273 pi centimeters squared. For volume, we're going to have volume of the cone plus half of the sphere. So volume of a cone is base times height, 1/3 of that, 1/3 pi r squared h, plus for the sphere is half of 4/3 pi r cubed, or 1/3 pi times r, which is 7 squared, times h. Well, h is here, so we have to find h, and by the Pythagorean theorem, we're going to say that 7 squared plus h squared is 25 squared, okay? Or h squared is 25 squared minus 7 squared. Or h squared is 576 when I take the square root of that answer. H is 24. Half of 4/3 is 2/3 times pi times r, which is 7 cubed. Now, I can see that a 3 will cancel out with part of this 24, but because this is also over 3, I am not going to cancel this. I'm going to keep this in terms of thirds. So 7 squared times 24 gives us 1176 pi over 3, plus, here I'm going to take 2 times 7 cubed and get 686 pi over 3. And that's why I didn't reduce that, because I know that this is going to be a 3 here, and to add fractions, you have to have a common denominator anyway, so we'd be undoing our cancellation there. It caused more work that way. But if we add these two together, we get 1862 pi over 3, and that's centimeters cubed for volume.